It's almost the end of Dreamforce, so thank you for making the time to come here and attend this session on Heroku Connect. My name is Rob Zaire. I'm a product manager in the Heroku Cloud, or sub-cloud. We're part of the platform. I work on our data services. So I'm here today to talk to you about Heroku Connect and how Heroku Connect can be used in tandem with Heroku Postgres to give you an integration solution for Salesforce data and really what it is, what it's used for, and I'll give you a short demo and answer any questions you might have. I know you've seen this multiple times today. This, obviously, if we were showing you any forward-looking features or talking about them, you only want to take into account what's generally available in any purchasing decisions. I won't talk about any futures today. Basically, we're going to go through what Heroku Connect is, how it's used, what the value prop is, and demo followed by Q&A. So Heroku Connect is part of a family of 4 fully managed data services within Heroku. We have Heroku Postgres. We operate about 1 million clusters of Heroku Postgres. We've been doing it since almost day one for 10 plus years. You can go anytime and check the status.heroku website. It'll give you visibility into availability. Now, that's aggregated across all of Heroku. And you'll see there is minimum of 5 nines reliability at any given point in time. So we've been doing this for a long time, and we've really put a lot of focus on making it easy for an application developer to leverage the power of Postgres easily in their application. Now, this talk is focused on Connect, so we'll save that for a little bit. We also have 2 other services. Redis, which is you probably know, is a high-performance in-memory key value store. Right? So it's really complementary in many cases to the database because you can use it to offload the performance hit to the database by caching data. You can use it for session management, and you can use it for queuing. And lastly, there's Kafka, high-performance distributed message bus. So those are our 4 services. We're going to talk today about Heroku Connect. So what is it? Well, data integration as a service is the simplest way to describe it. It supports 2 data integration patterns. One is replication, right? So physically moving records from Salesforce to Postgres and optionally back. And the second one is virtualization. Sometimes people will talk about an integration by reference pattern. And that's what we mean there. Connect is always a part of a triad. So there's a Salesforce org, a named org, and a Postgres schema. And it sits in between and handles the integration. Again, one of these 2 patterns. So let's dig into those a little bit and find out how it's used and what it does. Well, Heroku Connect is most often used, again, being in Heroku, to facilitate development of applications, logic, analysis. So when we say extend CRM, that's sort of a marketing speak for leveraging the power of your CRM together with the power of the PaaS so you get the best of both worlds. And what that means in practice is if I have complex logic that works in service to a business process defined in Salesforce, it may make a lot of sense for me to externalize that logic. If it's computationally intensive, if I want to isolate the performance, or let's say the resources needed to compute that logic from my CRM, well, I'll model that in Heroku. I've got a choice of a number of languages, development, build packs, etc. And I can seamlessly integrate that with my process in Salesforce. So that's an extend CRM use case. Another one is building a field service application or a customer service application. Again, building that in Heroku, but having that tight integration with Salesforce. Engagement apps come up commonly, so a loyalty app, anything that's customer facing where you want to leverage the power of Salesforce, but build a compelling application. 2 more use cases that come up. Multi-org, I'm sure many of you are in organizations that have multiple Salesforce orgs. When you want to do very sort of, I would say, simpler consolidation scenarios where you want to get a unified view of a customer, an account, contacts across different clouds, you can use Heroku Connect to synchronize that data into Postgres do some modeling and transformation in the database, and then optionally sync that back to a, let's say, a unified org that gives you that view. This is not, to be clear, you've probably heard a lot about Customer 360, and when we GA that, that's going to be an incredibly powerful solution and more or less out of the box. This is more what you would do today, and it gives you a little bit more customization. Lastly is analytics and insight. It's pretty self-explanatory. When you get the data into a relational database, basically it's easy to manipulate, easy to access via any BI tool, easy to combine with other data. So we talked about these two patterns. Let's talk about them a bit more. One is synchronization. Now you can set synchronization to be from Salesforce to Postgres one way and just leave it at that. Or you can have it be bi-directional. So in one of the use cases, we talked about building a customer service application. As a part of that, you undoubtedly would allow your customer to, let's say, update their contact information. If you sell different plans, you may want your customer to change the plan type or level. These would be examples where you'd want to then push that data back into Salesforce. In terms of scale, we get asked about this all the time, right? Can you handle 50 million records? Can you handle 100 million records? Well, we have individual customer instances that are well north of 1.5 billion, close to 2 billion. The service itself manages about 20 billion rows of Salesforce data across 6 global data centers. Over the last month, on our busiest day, we processed 3.5 billion transactions. So the scale is there. The ease of use is also there, right? So one of the ways I describe what Heroku Connect is it's more of a data integration SaaS, right? So ISaaS, integration software as a service. It's not a platform that you develop on. It works to enable you to bring the data into Heroku and do the development, but it's very easy to configure. There's minimal configuration. You can use the UI, you can use the command line, you can use the API. The net is minimal configuration, easy setup, super fast time to value. That's kind of the mantra of Connect. It by itself is not a development platform. The way sync works, we get asked this a lot too, right? How do you figure out when something changes? How does the system work? Well, it's a polling based. So we will poll Salesforce based on a configurable interval. We also have a mode that's totally complementary or can be used standalone that works based on streaming API notifications. So we'll get notified of a change and we'll do an on-demand poll. So that's just to be clear. It's always polling based, but we can either do on-demand poll, scheduled poll, or both. We read data in a highly parallel fashion. We write in a very fast, but we serialize it for reasons of data consistency because we're a sync engine, not a bulk load engine. So we want to make sure the integrity of the order in which the data is written and the dependencies that exist in the Salesforce data model, that those are respected. So that's how we write. Consistency. I mean, and here what I'm talking about is sort of the geekier developer view of consistency, right? When you think about databases and distributed databases or NoSQL databases, we work in an eventually consistent mode, right? What that means is that at any given point in time, there may be a difference between what's in Salesforce and what's in Postgres. The delay is typically very small, but it's there. And that can, for example, cross the boundary of a master detail, parent-child type of relationship. So that's why we talk about eventual consistency. In reality, if you set up Connect to work as aggressively as possible, and you've modeled everything, let's say, to be geographically co-located, you have a healthy database, a well-performing org, it's in this sort of like, seconds to low minutes as the latency. So pretty low latency. Conflict resolution, really simple. The last writer to Salesforce wins. The last writer may be Connect. It could be any other system that's pushing changes into Salesforce. The key thing to remember is Salesforce is a system of record. Connect is the sync engine. Postgres is a copy of a subset of the data. Okay, Second pattern, data virtualization. We implement this using an open standard, open data. The current version of the standard is 4.0, which is what we implement. The service that we implement is essentially standards compliant, meaning any OData client can access the data using this standard. It's essentially a REST wrapper for the database. Salesforce Connect is obviously they're part of the same family. We do a lot of testing with Salesforce Connect to make sure that that experience is seamless as possible. Many people don't realize this, but even this virtualized data pattern, right, where I'm accessing the data in real time, right, I'm going to open up a connection, query for the data, process the result set, and display it. That's how this pattern works. You can actually write back data using this model too, right? So it'll flow through our OData service and we'll push it into Postgres. So it's bidirectional. People don't always expect it to be. From an efficiency standpoint, take the scenario where your application is logging data. Maybe it's data from some smart devices that you've sold to customers that are connected and they're logging situations. And then you have a customer, encounters a problem with this smart device, calls your call center. The call center was using Service Cloud. In the context of that customer inquiry, you would like to see, obviously, what they purchased, but the relevant logs become really useful. But you'd never want to write log data to your CRM. That's just wasteful. It's kind of inappropriate data to have in a CRM. So many examples of this where being able to dynamically, contextually reference this external data makes a lot of sense. And that's one of the key drivers behind this type of integration pattern. The power, I think, comes from the fact that you don't have to manage moving the data around. The interfaces are open, very easy to understand. And in a Salesforce context, you have the Salesforce external object, which behaves like 90% like a native object. So you can incorporate it into workflows and processes in Salesforce. Okay, let me show you a brief demo of how this works. And we'll see if excellent. Okay. This is the Connect dashboard. Do you remember I told you it was a lot like a SaaS, right? It feels more like an application. This is a mapping that I've created a while back. Actually, my colleague created it, if I'm totally honest. And you can see here that it's reporting the health of the mapping, right? So everything is good. The current state is idle. There's no changes being pushed through. Basically got 16.1 million rows on either side of the continuum. And if you look below, you'll see, we wrote some records. There's some activity here. It was essentially some polling activity. Now we'll actually go over here and see every Connect instance, which is what we're looking at here, is defined by a number of things. One is the Salesforce org, the other is the Postgres database, and then it's the integration. The integration materializes as what we call a mapping. A mapping is essentially an object in Salesforce that I'm interested in synchronizing in Postgres. So here you can see my mapping is an account mapping, and I can go down and look at all the various fields in the mapping. What I can also do is create a new mapping. So we'll query the Salesforce instance, get the set of objects that are available. You can see sort of there's many, many things I could possibly grab. I'll just grab the event object. And you'll see a couple of things. This is the editor for defining the mapping. Again, minimal configuration, really straightforward. We have a framework built into Heroku Connect, which we call design time validations. And that's what I've triggered at the top that says, hey, accelerated polling isn't available for this event, this type of object. This is an example of the intelligence that's built into Heroku Connect. We have a deep understanding of the Salesforce APIs and the Salesforce objects, as you'd expect, being part of Salesforce. And we're able to, for example, communicate at design time if something is not supported, or should you make a choice that we know is not going to ultimately scale well. So let's look at the polling frequency. In this case, Again, I can take it down to 2 minutes. The accelerated polling option, remember that's listening for updates via the streaming API, not supported for this object. I could make it bidirectional, right, if I want, and I get another warning that says, hey, Rob, if you're going to do a read-write mapping, you really need a secondary identifier. This is for sort of handling race conditions that can develop when you're writing from basically the same object from two sources. So I'll spare you that those nuances, but I'm happy to answer them as a part of the question time. And so you'll scroll down essentially. I would pick the fields I'm interested in, save the mapping, and that's all there is there. We log everything, including audit events. So who came in and made what change when. This is new. We built this in service to our Shield offering, which was high compliance. So it's a HIPAA compliant or HIPAA compliance ready, and that was released a number of months back. There's a data explorer, again, makes it really easy for you to browse the mapping, and you can see, for example, a timeline of changes. I don't have that here, but you can also kind of do spot checks. It's really about spot checking. Obviously, when the data gets up, it's a little bit not the most scalable way. When it comes to OData, you know, it's the same theme, right? So there's an endpoint that's been configured because I've enabled it. And I'm able to then choose which of these objects I want to expose through my OData interface. So these can be, just so you know, any objects in the database. So they don't have to be objects that we've synced from Salesforce, right? Many times that's actually not going to be the use case. Many times it's actually a table that I've created or a view that I've created in the database that I want to expose back to Salesforce, again, because it's not native Salesforce data. Okay, so that's a quick look at Connect. Let's flip back to the slides and make sure displaying correctly. All right. So I'm going to anticipate some questions. You're looking at what I've shown you. Maybe you knew or you're wondering, how have we built it? We've built it using completely publicly available APIs, right? We don't use private interfaces. We use everything we use is well documented, and you could use it yourself. So why wouldn't you build this, right? Or why wouldn't you go and model this in a really powerful ETL tool? Few reasons. API calls are whitelisted. So part of the Ohana, so the Connect works by using the bulk API, the SOAP API, the streaming API. All those interactions with Salesforce will not count against your API limits. When you're working with large data sets and large data volumes, it really adds up. Relationship intelligence, understanding the Salesforce data model and how it works. What happens when there's a maintenance window? It just keeps working. We queue up changes and process the queue after the maintenance window, or any type of connectivity. You can generalize any type of connectivity issue. We analyze the data volumes, and so we'll use the right API depending on how much data has changed. We can adaptively change the batch size if we observe a performance issue. We use server-side PK chunking to take a big batch and split it up into small ones. And we have client-side, Connect being the client, we implement PK chunking on that side as well, right? So this allows very, very large data loads in a scalable fashion. Error handling and recovery, you just saw, you know, a little bit of that. There's a lot built into the system. There's intelligent notifications that will go out to you should we detect problems that we can't repair. We take a snapshot of the Salesforce schema at the time you create your mapping. And as you know, the bane of any integration solution is the world changes, your integration doesn't, and something is broken. So we'll notify you proactively if a field that you've mapped in Salesforce got deleted, or if the data type changed. And if it's a change that's safe to make, like just increasing the length, we can do that automatically. And lastly, 24/7 developer support. So that's Connect. It's a little integration service. It's not nearly as broadly focused or broadly powerful as something like MuleSoft, which we're really excited to have be part of the family. It's more narrowly focused, but it's really designed to save you a ton of time and help you get focused on building a compelling application or otherwise solving a problem. So with that, I'm going to skip this one and we'll go straight to, because we're a little bit out of time. I'll go to questions. Thank you for your time. I'll stick around here should you have any questions.